Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3551 Distributed Computing. The unit is Consensus and Recovery. In this video, we are going to discuss about issues in failure recovery and checkpoint based recovery. Issues in failure recovery. In a failure recovery, we must not only restore the system to a consistent state, but also appropriately handle messages that are left in an abnormal state due to the failure and recovery. The computation comprises of the three processes, that is the PI, PJ and PK, connected through the communication network. The processes communicate solely by exchanging messages over the fault-free and FIFO communication channels. Here in this example, the checkpoints are CI0, CI1, next CJ0, CJ1, 2 and CK0, CK1, CK2. The messages are A to J. The restored global consistent states are CIJ1, CI1, CJ1, CK1. The rollback of the process PI2 checkpoint CI1 created an orphan message H. The orphan message I is created due to the rollback of the process PI to the checkpoint CJ1. The messages C, D, E and F are potentially problematic. That the message C is a delayed message, message D is a lost message. Then the last messages are handled by having the process keep a message log of all the sent messages. Message E and F are the delayed orphan messages. After resuming the particular execution from their checkpoints, processes will generate the both of these messages. Checkpoint based recovery contains, there are three types of categories. First one is the uncoordinated checkpointing, then second one is the coordinated checkpointing, the next one is the communication index checkpointing. Uncoordinated checkpointing. Uncoordinated checkpointing contains means each process has autonomy in deciding when to take checkpoints. The advantage of this checkpointing is the lower runtime overhead during the normal execution. The disadvantages are domino effect during a recovery. Recovery from failure is slow, but processes need to iterate to find a consistent set of checkpoints. Then each process maintain multiple checkpoints and periodically invoke garbage collection algorithm. And it is also not suitable for the application with frequent output commit. The processes records the dependencies among their checkpoints caused by message exchange during the failure free operation. Then direct dependency tracking technique. Assume each process PA starts with the execution and with an initial checkpoint CI, 0. I, X is a checkpoint interval between the CI, X minus 1 and CI, X. When PJ receives a message M during the IJY, it records a dependency from IJX to IJY, which is later saved onto the particular stable storage when PJ takes the CJY. In this figure, there are checkpoint interval and the checkpoints are mentioned. Coordinated checkpointing. Coordinated checkpointing contains the two types of checkpointing. First one is the blocking checkpointing, then next one is the non-blocking. Blocking means after a process takes a local checkpoint to prevent orphan messages, it remains blocked until the entire checkpointing activity is completed. The main disadvantage of the particular blocking checkpoint is the computation is blocked during the checkpointing. Non-blocking checkpointing means the processes need not stop their execution while taking checkpoints. A fundamental problem in coordinated checkpointing is to prevent a process from receiving applications messages that could make the checkpoint inconsistent. Then The example for the checkpoint consistency is, suppose a message M is sent by a PO process. After receiving a checkpoint request from the checkpoint coordinator, assume the M reaches P1 before the checkpoint request. This situation results in an inconsistent checkpoint since the checkpoint CN shows the receipt of the message from. Then another one example is the solution with FAFO channels. If the channels are in FAFO, this problem can be avoided by proceeding the first post checkpoint message on each channel by a checkpoint request, forcing each process to take a checkpoint before receiving the first checkpoint message. These are the two examples. In this first example, that is the checkpoint consistency. Then second example, a solution with the FAFO channels. Then next one is the communication-induced checkpointing. There are two types of checkpoints. First one is the autonomous. Then second one is the forced checkpoints. The autonomous means that these checkpoints that a process that independently are called local checkpoints. Suppose while this process is forced means that are called forced checkpoints. The autonomous checkpoint is otherwise known as local checkpoint, forced checkpoints. Next, the communication index checkpoint piggybacks protocol are related to information on each application message. The receiver of each application message uses piggyback the information to determine if it has to take the forced checkpoint to advance the global recovery line. In contrast, the coordinated checkpointing, no special coordinated messages are exigent. There are two types. First one is the model based checkpointing, then second one is the indexed based checkpointing.